In this video, we dive into explaining carbon and its compounds. Now, probably asking yourself, why are we wasting a lot of time studying about this carbon and its compounds? The first thing, carbon is atomic number 6, and this means that its electronic configuration shall be 2, 4. 2 electrons in the first energy level, then 4 in the next energy level. Now, carbon can either gain 4 electrons or lose 4 electrons to attain stability, but it cannot gain 4 electrons. Why are we saying that carbon cannot gain electrons to attain stability? It's because if carbon gains 4 electrons, this means that the total number of electrons will be 10, but we only have 6 protons in a nucleus. Remember, the number of protons is equal to the number of electrons is equal to the atomic number in an atom. Now, considering carbon before gaining the electrons, the number of protons shall be equal to the number of electrons, which is equal to the atomic number, and it is 6. But notice that if it gains 4 electrons, it shall end up with 10 electrons. And that will be a lot of work to a small nucleus with only 6 protons to hold 10 electrons. And with this perspective, it means that carbon cannot gain electrons. So the gaining of electrons, we do away with it. Now let us look at our scenario number 2, if it is possible or impossible. Losing of the 4 electrons. Number 2, you notice that carbon cannot also lose the 4 electrons because 6 protons in the nucleus hold the 4 electrons very strongly. So it will require a lot of energy to remove the 4 electrons, and hence carbon can neither lose 4 electrons or gain 4 electrons. So what does carbon really do? Carbon normally shares its electrons with other atoms for it to attain stability. Another fact about carbon is that when there is sharing of electrons, there will be formation of covalent bonds and hence covalent compounds. And this only happens to nonmetals. And this tells us that clearly carbon is a nonmetal, because covalent bonds are normally formed between two nonmetals. Let us go ahead and look at what are these covalent compounds. And for this, you must clearly understand that for an atom to be stable, then there are only 2 scenarios. Either it has 2 electrons in the outermost energy level, what we call duet, or it has 8 electrons in the outermost energy level, what we call octet state. Now, duet is normally for hydrogen and helium. Now, let us look at an example for this, and we first consider hydrogen. Hydrogen is atomic number 1. So this means that for it to be stable, it needs to receive 1 electron because its electronic configuration is just 1. So this means we can have this hydrogen with 1 electron and also this other hydrogen with 1 electron. So to attain stability, they will share electrons. So this hydrogen will have a circle up to this other hydrogen, and you notice that it has 2 electrons, and the same happens to this other hydrogen. And notice that if we cover this also has 2 electrons, and both of our hydrogens are stable. Let us look at an example that will make you understand this concept clearly. Let's look at chlorine, which is atomic number 17. This means its electronic configuration is 2 to 8 to 7. 7 meaning it needs 1 electron to be stable. So we shall have our chlorines here, each with 7 electrons. This is 2, 4, then 6, and lastly 7. We do the same for this other chlorine, 2, then 4, then 6, and lastly 7. So to attain stability, we draw the first circle. So this first chlorine will have a circle going up to these other chlorines, and it picks this 1 electrons. So there are 7 plus this 1, that gives us 8 electrons. We do the same for this other chlorine, and you notice that this also has 8 electrons. And both of our chlorines are actually stable. Now we can also represent this using a dot diagram by basically using a line. And this line is what we call covalent bond. And notice that here there is only 1 pair. That's why we have 1 line. Let's look at oxygen, which is atomic number 16, and its electronic configuration is 2 to 8 to 6, meaning it needs 2 electrons to be stable. So we shall have the 2 oxygens, then each with 6 electrons. That is, our 2 shall be at the bottom for this first oxygen, then another 2 at the top, and lastly the remaining 2 shall be here
and they are the ones that will be used for bonding. We do the same for these other oxygen. 2 shall be at the bottom, 2 at the top, and then 2 at this point.
Now then we shall draw 2 circles, each covering the 2 electrons in the other oxygen's electrons, and this is basically what we have.
So you notice that both of our oxygens are stable, with each having 8 electrons. We can also represent this using a dot diagram. That is, since we have 2 pairs here, this is our first pair, this is our second pair. So this means that here we shall have 2 bonds or 2 lines, which we basically call double bonds. Let's look at another example, that is nitrogen. It is atomic number 7. Its electronic configuration is 2,5. It needs 3 electrons to be stable. So we shall draw it here. We have 2 electrons at the bottom, then 3 here, then we do the same for this other nitrogen. This first nitrogen will have its electrons plus these 3, then for this other nitrogen, it will have its electrons plus these 3, and you notice that both of our nitrogens are stable. If we draw an E dot diagram, you notice that here we have 3 pairs, so we shall have 3 bonds, or what we call a triple bond. Next, let's look at methane. Now, methane has 2 elements, that is carbon and hydrogen. Carbon is atomic number 6 and hydrogen is atomic number 1. The electronic configuration of carbon is 2,4 and that of hydrogen is just 1. Now, since we have 1 carbon and 4 hydrogens, we shall have carbon at the center, then the first hydrogen here, then these 2, and the last shall be here. Now we need to draw the bonding diagram for this. Now the first thing is to know the number of electrons needed for stability. Carbon needs 4 to be stable and hydrogen needs 1. So we have carbon with the 4 electrons it has, also hydrogen each having 1 electron. So for this carbon to be stable, it means that each of the hydrogens will give it 1 electron. And you notice that our carbon has 8 electrons. But in return, it will also have to give each of the hydrogens 1 electron. And you notice that all our hydrogens too are stable because they have 2 electrons. And our carbon has 8 electrons. And all of them are actually stable. We can also draw an E dot diagram for the same by having carbon and having a single bond to each of the hydrogens because we just have 1 pair. Now we shall conclude this lesson by looking at the properties of covalent compounds. Now the first property is that they have low melting point and boiling point because they have low intermolecular forces. Despite them having covalent bonds between the atoms, the molecules are normally bonded by intermolecular forces which are easy to break. Number 2 is that they are normally poor conductors of electricity, and this is because
They have no charged particles.
free to move for electrical conductivity. And this is all for our today's video. Probably we shall cover
The next concepts.
in our upcoming videos. So go ahead and subscribe to this channel. Turn on the notification bell so that you get notified whenever we upload a new video. Please like, comment, share, and don't forget to subscribe once again. Thank you for watching this video.